that I had my knee surgery a while ago, and my knees are doing so much better than I have a right to expect. But sometimes I just don't understand how difficult some things will be. So I didn't really want to chaperone the play because I knew it would hurt my knees. But I did it in part because I really like to see the kids in the play. I like to see all of their hard work come to fruition. And I did it anyway, even though I knew it would hurt. And I really don't think I thought it through thoroughly, because after that I had the first day of softball. And yesterday for softball, I stood up probably for about 2.5 hours in a row without sitting down. And my knees are hurting last night, big time. But you have to push through. I have to. It's just part of the price to be successful. I talked to so many people who've had the same surgery I did. One is a high school teacher who had a double at the same time. And he said, look, I remember how much it hurt. I remember how difficult it was. He said, and it took months and months and months and months and months. But one day, it all went away. And I felt absolutely no pain. And I kind of equate that to what you guys go through with school sometimes. Because school can be painful and school can be tough. But the truth of the matter is, there will be a day when you feel no pain. But you have to work for it. If you think, like I know people who, when they had their knee surgeries, they didn't go to physical therapy. And physical therapy is a lot more painful than homework, I'm telling you now. And they're right now walking around with canes. And they had their surgeries before I had mine. So you just have to find a way to will yourself to step up, Fernando, and to make these really good things happen. And to do the best that you can possibly do. And that's what we're trying to teach you. That's really the lesson behind school. The rest of the stuff, that comes along for the ride. But this ability to do the right thing and to rise to the occasion, that's what it's all about. So I am very, very proud of most of the work people have done all year long. And I accept the fact that there's going to be times during the year when we're not going to be at our best. But you need to understand there are certain times when you just have to make it happen. And we are at that time. From now until the vacation and when we return from the vacation. We really have to be at our best. You know, I coach wrestling, so that just tells you right there that I'm a fighter. I like dogs that are tough. That tells you what I admire and what I respect in something. And personally, I don't think anyone can make a test that's too tough for me. I don't care what that test is. I dare the people who make tests to make a test that I can't kick butt on. Because I believe in myself, I believe in my work ethic, and I believe in my intelligence. Likewise, I hope you develop that same sort of fighting attitude in your schoolwork, because this is your future we're talking about. We're talking about you guys having the best life you can possibly have. And to do that, it requires a focus and an edge, almost daring people to make something too tough for you. And saying, I will do whatever I have to do to work as hard as I have to work to make sure that you can't get in the way of my success. Sometimes when I was in school, this is one of the things I figured out. Sometimes kids say, oh, I hate such a teacher, God bless. I'm not going to do well in their class. And I always look at kids and I say, you know what? I understand what you're saying, but here's the thing. When I was young, what I always said to myself is, I will not let any teacher stand between me and my success. Whatever my success is going to be, I don't care how much that teacher hates me, I don't care how much I hate the teacher, I am going to make this happen. Because at the end of the day, if you don't do well, who suffers?
Us.
You do. That's right. We don't want that to happen, okay? And that requires sometimes that you come in the room and you're in a mood to goof around. I'm with you. But you don't. You don't because it's not the right thing to do, because you're going to suffer and we don't want you to suffer. Okay, so anyway, here's the first question, and it said, which of the following is not equivalent to 1/9? Now, yesterday we talked about test savvy. And what it means is, well, let's pretend for a minute that I don't even know what 1/9 is equal to, and I don't know how it relates to my choices. But I do know how to simplify every choice. And if I go through, I keep the base, what do I do to the exponents? Add them. So this is 3 to the 2, 3 to the negative 2, 3 to the negative 2, and 3 to the negative 2. So the question said, which one is not equivalent to it? Well, obviously, when 3 of the choices are the same thing, which is the one that's not? Everybody? A. This has to be the one that's not. Now, let's go back to what 1/9 means. This is a reciprocal. When it's a reciprocal, what kind of exponent am I dealing with? A negative exponent. Negative exponent, reciprocal. So here's my negative exponents that indicate to me to do reciprocals. And I also realized, just by a connection in my mind, that isn't 9 3 to the second power? Right? Is it 9 3 squared? You with me on that?
Yeah.
Okay. So since it's a reciprocal, it can't be 3 squared. It has to be 3 to the negative squared, if you will, or negative 2. So therefore, the answer is choice A. Now, I'm going to show you 2 ways to do this one. I'm going to show you the way that we would want you to be able to figure it out. And then I'm going to show you the way with test savvy again, understanding how to do things with a test. It says here, equation of line. As soon as you think of equation of the line, what do you think of? Y equals mx plus b. Good. Now, what does m stand for? Come on, talk to me. Slope, which is also known as the? No, come on, starts with an R. Rate of change. Everybody say slope is rate of change.
Slope is rate of change.
Good. And what does B stand for? God bless. Now, how do I find the B in the table? My 6th graders can answer this question. How do I find B in the table? What is it? Come on, loud.
0.
Pairs with 0. Very good. So now I know the B is negative 3. And you know what? That's all the work I did here, because I looked through, and there was only one that had a y-intercept of negative 3, so I knew it had to be C. But just in case, let's also find the slope here. How much do I go up from 3 to 13? 10. And how much do I go up from, negative 3 to 13, I'm sorry, negative 3 to 13 is 16. God bless. And how far do I go up from 0 to 8? 8. So then that's 16 over 8, which is 2, and in choice C, it's y equals 2x minus 3. Now, there's another way to do this, which is important for you to know. Let's say that you try it the way that I just did, God bless, and it doesn't work. You try it and you're not coming up with the right answer. Maybe you're making a careless mistake somewhere. Happens to all of us, myself included. Now, what you can always do is plug each of these choices, all 4 of those choices. You can plug them in and see which of these choices works for all of them. So for instance, let's do 10, 17. Let's do a choice that does not work and then a choice that does. If I plug in a 10 for x, what's 2 times 10? 20. Is 20 minus 13 17? No, it's 7. So that can't be the answer. Let's try B. What's 13 times 10? 130 minus 2. Is that 17? No. Let's try this one. What's 2 times 10?
20.
20 minus 3. Ooh, that might work. Let's try the last one. What's negative 3 times 10? Negative 30 plus 2. That's not going to be negative 7. Pardon me. It's not going to be 17. So the only one that could possibly be the answer is C. So you could always just plug all of the values in and see which one works. It has to work for all of them. It doesn't. It can't just work for one of them. Okay? Any questions so far? All right. So those 2 questions could be answered just understanding test savvy and by eliminating choices and using the way a test is constructed to our advantage. Okay. Now we can't do it so easily. What's that? Test savvy? It's wiseness. It's understanding how a test is made. Sometimes, I'll give you a good example of savvy that you have that I don't have. Video games. How many people here play video games? Now, when you play video games, did you ever hand the controller to an adult?
No.
Yeah.
Oh, okay. Did you ever do it for comedic effect?
Yes.
In other words, for comedy.
Yeah.
You hand it to the adult, and they don't even know how to use the buttons.
Don't even know where the power button is. They're like, how do you turn this on? How do you turn this on?
All right, well, most adults are not as good as most kids. Now, excuse me. So here's my point. You have played, oh, stop it, you've got to grow up. At some point, you do so many video games that you realize certain techniques that tend to work in like a lot of situations. and you use that to your advantage. Now, I don't know those techniques. So if someone hands me the controller, I need to like really struggle with the controller before I even attempt to be good at the games. But I could give you a brand new game that you have never played before in your life. And you can be pretty good at it because there's a similar thread between all video games. And kids are just like, oh yeah, no, you don't have to show me, I got this. A lot of times you don't have to show them anything. They figure out right away how to do it. I struggle with that. Well, on tests, just like there are common threads in video games, there are common threads in tests. And you learn to look for those common threads. Now, number 3, a sequence of transformations. You know what makes this a hard question? Yeah, that's exactly it. It's a reading question. A sequence of transformations was applied to a right angle. Now, does anybody remember what the transformations are? There's 4 of them. What's one? Rotation, dilation, 2 more. Reflection. Translation. Okay, there we go. There's 4 of them. So a sequence of them. So one after another, whatever. They're done to a right triangle on a coordinate plane. That means XY. The transformations used were only translations and rotations. So there was no dilations and there were no reflections. Which statement could be about the resulting figure could be true? And the answer is D. If you start with a right triangle, you have to get back a right triangle. Okay? I'm not going to change the angles when I spin it. So if there was a 90-degree angle in the beginning, there'll be a 90-degree at the end. If I slide it up, down, left, right, I'm still going to have a right angle. So it has to be a right triangle when we're done. So that eliminates choices B and C. Now, what's the only transformation that changes size? A dilation. Was a dilation used in this problem?
No.
No. So choice A says the sides are not the same. Choice D says the sides are the same. Which one does it have to be? Guys, do I do a dilation? Yes or no?
No.
No. So can the sides change?
No.
No. Which choice, A or D, does not change the sides? D. So therefore, the correct choice is D. Now, as far as number 4 goes, number 4 works something like this. I forget if it was A, B. I think it was B. Right? Didn't the choice work out to be B?
Yeah.
All right. So we start here. It's going to flip here. Now, one of the things to keep in mind is that, and then I'm going to slide over and up, so it has to look like this. You need to pay attention. I'm sorry, this is B prime. This would be C prime, and this would be A prime. You need to pay attention to where the primes are. There's 2 choices. One has A, B, C here, and A prime, B prime, C prime here. One of them has A, B, C here, and then the primes over here. The A, B, C goes first. You see, it starts with this and it becomes that. So you have to look for the one where it slides to the left. If you chose the other choice, it's not sliding to the left, it's sliding to the right. So you need to be careful when you look for that choice, okay? Any questions? All right. So now, let's go to the next phase. Come on. Okay. Let's go to the next phase, and what we're going to talk about is today's Do It. Which term expresses the relationship between angles 1 and 8? Let's look at the 4 choices. Are angles 1 and 8 adjacent? Adjacent means next to each other. Are they next to each other? No. Congruent means equal. Are they equal? What kind of angle is 1?
Obtuse.
What kind of angle is 8? Obtuse. Bingo. Lights, lights, lights. Bells, bells, bells. Ring, ring, ring. Congruent it is. Which 2 angles are complementary? Complementary means adds up to 90. Elizabeth? Which choice? A, B, C, D?
Sorry.
A, let's see. Angle BAC, that's this guy. And CAD. CAD, which is this guy. Good, yes, those 2 angles together make the right angle we have there. A is correct. Okay, next. And what we're doing here, guys, is we are reviewing for all the geometry that's going to be on our test. So we keep coming back to it time and time again.
When's our next test?
Oh, by this I'm talking about the state test. Our next test won't be for a while. Next, Based on the Pythagorean theorem, which relationship is true for the sides in the triangle shown? Pythagorean theorem says what, everybody?
Legs.
Oh, it's B.
Well, what does Pythagorean theorem say?
Leg squared
Keep going.
plus leg squared equals
Hypotenuse squared. Very good. We always want to draw. We always want to draw across here. Label this the hypotenuse. So I'm going to get this leg, 6 squared, plus this leg, 8 squared, is the hypotenuse squared. 6 squared plus 8 squared is 10 squared. Okay, this one, I haven't taught you yet. I taught you part of it. We said that whenever you read ratio, you think x. Boys, Ulysses, Jason? Whenever you read ratio, you think x, so it's going to be 2x, 3x, and 4x. The thing I haven't talked much with you about that I need to talk more about over the next few days with you is the fact that the three angles of a triangle always add up to 180. What do the three angles of a triangle always add up to? 180. So I'm going to add, and I get 180. Same size situation. That's 5 and 4 makes 9x is 180. Divide by 9. X is 20. Find the smallest angle. That's the one that's 2x. 2 times 20 is 40. So 40 is the correct answer. So we did lots of these with supplementary and complementary. We just never did it with the three angles of a triangle. Now we're going to add that in. And the big thing for you to remember is, this is for visual learners here, the three angles of a triangle all add up to 180 degrees. 180 degrees.
How'd you get 40?
Because 2x means 2 times x. X is 20. 2 times 20 is 40.
Oh, yeah.
Okay, now next. Quantitative or qualitative? This is one of two things we talked about yesterday. Quantitative means it has something to do with numbers, almost always. And qualitative means it's not with numbers. Alan, what do you think?
Qualitative.
That's right, because it's your favorite color. Colors have nothing to do with numbers.
What is your favorite color?
So it's your favorite color. I don't really have one. I like earth tones as a general rule. Number 6, quantitative or qualitative? The weight of a newborn puppy. Quantitative, because it's an amount. Very good. Okay. Now, the last thing we talked about in class yesterday that we kind of ran out of time with, that I just want to mention briefly, is the idea of bias. Bias, there's a whole section of the police force called bias crime. Okay? Bias crimes are crime because of prejudice. So, for instance, if you harm someone because of their religion, and that's why you single them out, we call that a bias crime. If you harm someone because of their ethnicity, we call that a bias crime. It means you're prejudging them. And you're doing it just because they are what they are, and that's wrong. Now, bias is something that exists in this world. I would say, honestly, I don't think there's a lot of bias per se with the person's skin color. At least it's not with me, and I don't think it's with most people I know. There may be places in the world where it's true, but I don't see too much of that. But you know where I see lots of bias?
Where?
Music.
Oh.
I see bias with music all the time. For instance, Alan, what kind of music do you like? You like rap crap. Now, I clearly hate rap crap. Now, how old am I? I'm 51 years old.
Are you really?
Yes, I am.
He said 80.
Thank you so much. At 51 years old, I did not grow up with rap crap. I grew up with music like Bruce Springsteen
Classic.
and The Who.
Country.
Classic,
Yeah.
classic
All this
rock and roll.
classic.
Now, so I would tend to like that. Now, Rena mentions country. If you were to drive down south,
California.
excuse me, if you were to drive down south, what do you think is more popular?
Country.
Country or rap? It's going to be country. If you drive into New York City, Philadelphia, LA, it's going to be rap. Now, if I decide that I want to see what the most popular type of music is for kids between age 12 and 22, and I say take a survey, if I take the survey in New York City, what do you think the answer is probably going to be?
Rap.
Rap. But if I take the same exact survey and I go down to Georgia, what do you think the answer is going to be?
Country.
Country. And that's an example of bias. It doesn't mean the New York City people are wrong or the Georgia people are wrong. It just means that because of the culture they live in, there's a certain perspective that they're likely to choose. Another, let's say I wanted to find the average height of somebody in 8th grade. If I choose to randomly sample 8th graders all over the place, that's random, that's not biased. But if I go to just the basketball team, don't the basketball guys tend to be the taller guys?
Yeah.
So I'm probably going to get the wrong answer because I went to basketball, okay? If on the other hand I went to gymnastics, gymnasts tend to be a little smaller, they would tend to be smaller than average. So bias means something that's going to mess the data up a little bit, okay?
Not accurate.
All right, so here's the next thing that we're going to talk about. Univariate versus bivariate. Now, here is a great opportunity to do some swirling here. What's a variable in algebra?
A letter.
It's the letter. It's the thing that can change. And that's why we use vary, because vary means to change. Everybody say, vary means to change. Okay, now, vary, oh, I can even do it this way, is right there. Same thing in bivariate. Now, I have to approach this delicately. We all know what bi means, okay?
Bye.
Not that kind of bi, all right?
I get it.
All right.
Yeah, we
How many
understand.
wheels does a bicycle
Two.
have? 2. How many
Just
wheels does a unicycle have?
3.
One.
That's a tricycle.
1.
1 wheel on a unicycle. Okay. So when I do univariate data,
Come on, Doc, let him teach.
you know what? It's not that. It's let you learn. Okay. Now, univariate means one. Uni means one, right? We're all with that. One change. Univariate means one thing is varying, one thing is changing. What do you think bivariate means? 2 things are changing. Okay, so some examples of things with univariate data include histograms, stem and leaf plots, circle graphs. You did those last year, I think. And in these, one thing is changing. For instance, univariate data might be, how did you do on today's quiz?
Oh, awful.
How many people got 75?
Yeah,
How many people got 100? How many people got 50s? That's univariate data. It's all about one score.
I got 0.
But sometimes we do bivariate data. That means that 2 things are changing simultaneously. So for example, here's a really good example of bivariate data. How many people here like fishing?
I love it.
I love fishing too. Now,
One day.
I like
there is a
goldfish.
thing, guys, listen, we're in a bit of a rush, so I don't want to get distracted here. There is a thing called electroshocking. Now, with electroshocking, what happens is they go up and down a river and they put electrodes in the water in front of a boat. And when a fish swims between the electrodes, it gets stunned and it floats to the surface. It doesn't die. They can scoop it up. They kind of get knocked out for a second. They can scoop up the fish and they can measure it, and then they put it right back in the water and the fish lives.
That's cheating.
So, well, what they do is they want to see how big are the fish getting in the river.
When
Okay?
you're catching them.
So, no, they're not catching them. Everything is released. This is what like the New York State Department of Environmental Conservation would do. People don't do it. NCON does it. So here's brook trout. Notice 2 things are changing. When the brook trout is 10 inches, it weighs 6 ounces. Michael? When the brook trout is 13 inches, it weighs 15 ounces. When it's 16 inches, it weighs 30 ounces, and so on over here. What I want you to see is that 2 things are changing. What are the 2 things that are changing here?
The bigger it gets.
The length is one,
Oh, sorry.
and the weight, right. No, but Alan actually went a step ahead. Alan said, well, I can even come up with an idea. The longer the fish is, the more it weighs. And that's when we look to put 2 things together, and we're actually going to do that as a thing. And what we're going to do is we're going to create a scatter plot. So, I'm going to move this up a little bit in just a second, I hope. All right, good. So here's the data, and now we're going to create a scatter plot. So let's copy this down on your paper. It's really, really simple. Scatter plots are not necessarily exact. I'm going to put length on this one,
And width on the top.
weight
Oh.
on this one. And now, for ounces, I'm going to do 5, 10, 15, 20, 25, 30. I got to go up pretty high here. 35, 40,
So big fish.
45, right? And then over here, for length, I'm going to do 5, 10, 15, 20 inches. Now, all I do with a scatter plot is I plot points, and I make them where they line up. So, for instance, the first one was 10 inches and 6 ounces. So 10 inches, 6 ounces, I put a dot right about there. Does that make sense? I line up 10 inches with 6 ounces. Remember, On this axis, everything is ounces because it is weight. On this one, everything is inches because it is length. Okay, so now, next up, 13 inches, 15 ounces. Go ahead, find 13 inches and 15 ounces and make a dot. Don't worry about that. I can tell you at lunch. 13 inches, 15 ounces. There it is. 13 inches, 15 ounces. Next up, let's do 16 inches, 30 ounces.
Crap.
16 inches, 30 ounces. Next up, 22 inches, 71 ounces. That's like all the way up there. All right. Folks, very good. We will keep going on this tomorrow. That last thing was called scatter plots. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Ta-ta. See you later.
I'm going away
Why did
third.
you get on my testosterone?
I don't remember. Check with me at lunch.
We don't have softball
I
today,
don't remember.
right?
What's that?
We don't have softball.
No softball today, softball tomorrow. How's your arm feel? Good.
When is that real impact due? Because I'm going away Thursday for the whole week.
Tomorrow. Night. Oh, no. Tonight.
No, the one that was due.
Oh, that one's due like the end of the week we get back.
Okay.
All right?
Yeah.
And the videos will be up this week.
All right, awesome.
Actually, I hope to have them up today.
So if I bring that grade up, that will help me out a lot, right?
Yeah, if you bring that grade up, because I think